This video is for 14.2 homework. So if you are stuck on any of these problems, be sure to follow along with this video. So I'm going to be honest, there are a few questions that are a little trickier on this. And it's not, I don't think they're hard. I think the way they ask them is a little bit silly. So we will figure them out together. Okay. They're just not what I would do in my mind. So maybe to you, they'll make sense. So, number one tells us that the age of campers at a summer camp that have attended camp for at least 5 years are listed. So, here's all of their ages. And we are going to complete the dot plot for the campers' ages. So, one thing I want to show you is that if you are doing this in ed, so if you're doing it on paper, no big deal, just make your dot plot. So if you are doing this in ed, it starts with all of them having one, just so you know that they're there. So I think it's a good idea to drop them down because we don't know that they all have one. So drop it down and then you can bring it back up. So we'll do, right, 1 for 13. So raise it 1, 1 for 12, 1 for 15, and keep going. So go ahead and finish that. So if you are doing it on paper to find it, you just want to put a dot or an X or any of that, any symbol above there. So, right, I would say I have one that is 13, I have one that is 12, and we do our best to kind of line them up. So, right, they're not perfect, but I shouldn't have like one of them way up here and one down here. So then I say there's one with 15, then there's a 14, and I just go through every single one, stacking them on top of each other. So what is the most common age of the campers? So whichever one you made the highest is the most common. How many observations are there? So remember, observations just are representing a person or a thing that was looked at. So each of these are representing a person. So how many are there? Or you can count each of the dots. Okay, and then what percent of campers are over the age of 14? So it does not say 14 or older. It says what percent of campers are over 14? So, whoa, that is really big. I do not want to write that big. So my total, whoops, now I've got myself all backwards. So we want to put the part over the total. So we're going to look and you're going to count all of the kids that are 15 and 16, and that's going to go here. So your kids that are 15 and 16 are the part, and the total, you should have just done that, should be here. So your total comes from that previous question. How many total kids are there? So the campers over 14, count the 15 and 16-year-olds. And then our total is all the total campers. So when we're looking for percent, percent is always out of 100. So we will times our number here by 100 because we do the opposite to both sides. So times 100 times 100, and then divide by the total number of campers will give us our percent. So 15 and 16-year-olds, how many are there? Over total campers, how many are there? Percent over 100, always over 100, times on both sides by 100 to get rid of it, and divide by how many total campers there are, gives us our percent. Hey, number 2 tells us that a zoo has a population of endangered leaf-tailed geckos. So here's a leaf-tailed gecko. So this goes right along with what we've been talking about in science, right? So this is a nice camouflage it has to blend in there. So each year, the zoo records the number of eggs each female gecko lays and hatches. So every dot stands for one gecko that laid that many eggs. So this gecko laid 8 eggs. This gecko laid 7. This one laid 7. This one laid 7. So we're going to have to do some thinking here. So the number of eggs, right? So there's 8 here, 7 here. So each dot is kind of representing this number here. So what is the total number of eggs hatched in 1 year? So I'm not just counting the dots on this one. It didn't ask how many geckos they observed. It asked how many eggs. So every dot is representing a gecko that laid that many eggs. So this gecko laid 2 eggs. This one laid 3 and 3. So I can either do a couple ways. I could do 3 plus 3, or I could just say I have 3 groups of 2, and then 4 groups of 2, 5 groups of 3, so 5 times 3. And then this one has 6 groups of 4. And then we have 7 groups of 3. I guess I should say those backwards. 3 groups of 7. So 3 geckos, each laid 7 eggs, and then 1 gecko laid 8. So that problem here, so we'll do all of our multiplication first. So find out how many 3s there were, how many 4s, 5s, 6s, 7s, and then we add those all together to find the total number of eggs. So now what is the total number of geckos? So now it's asking how many observations, how many geckos did they observe? Well, each dot represents 1 gecko that they observed. So we just need to count up our dots for our observation here. What is the greatest number of eggs laid and hatched by 1 gecko? So it doesn't want to know the most common, it wants to know the biggest number of eggs. So the eggs hatched here is our greatest number. One of the geckos had 8 eggs. Now, what is the most common? So now we're looking for which one went up the highest, and that was the number that we saw most often. It was the most common. Okay, so here was the question that I was like, wait, what is this asking? Now that we've done this one, I think I understand it a little better. So hopefully we can do this together. So one of the zoologists splits the data and considers the top half of the data or the 8 greatest observations. So they come here, okay? And what percent, oh, here we go. I was missing this part of the question earlier. I was like, this is just not making sense. So what percent of the total eggs? So not what percent of the geckos, right? Because here's 8 and here's 8. So I was like, it's 50%. And then it was telling me that wasn't the answer. I was so confused. So it's important we read our questions carefully. So it wasn't asking what percent of the geckos. It wants to know total eggs. So we have this work up here that is really going to help us. So we're going to split our data here. And so here's the top part of the eggs. Here's our bottom part. So we're not going to be looking at this part right now. So we're looking for percent. So total, oh my gosh, I did it again. We want our piece over the total, the part of what we have over the total. So we've already figured out the total number of eggs in this first problem here in part A. So when we did 2 plus, here's 6 plus 8 plus 15 plus 24 plus 21 plus 8, that is our total number of eggs. So part A is going to go here. So this is from part A. This answer goes right here. Now we just want the top 8 geckos' eggs. So now we just need to look at this part here. So we have 6 times 4 is 24. 7 times 3 is 21 plus 8. So these eggs are our top ones, and they're going to go as our part here. Now remember, percent is always out of 100. So we're going to multiply by 100 on both sides. So we're going to take these top eggs, times them by 100, and then divide by the total number of eggs, so our answer from the beginning, and that will give us the percent of the eggs that are in the top half. So Hopefully that made sense. Once I read the problem and we'd found the total eggs, yeah, earlier I was like, they cut it in half. It's 50%, but they weren't asking about the geckos. They were asking about the eggs. So it's really important we read and understand, what is this asking? So each of these are representing a gecko that says how many eggs that gecko laid. Okay, so go ahead and try that. And so if you are doing it on paper, I just need to see your answer, and your work is a great explanation. So make sure I can see your work. If you are doing it in ed, let me get to number 2 here. So it is going to have some of this. So this is where the final answer goes. What was the percent? The 8 greatest observations, how did we find that? Well, we did this here, or the total of what? So when you did this problem, what did the top 8 observations equal in eggs? Then to find that percent of the total eggs, what were we really doing? Which is about what percent again? Okay, so go ahead. So if you're doing an ed, you do need to know the percent, and then you explain your work by dragging those up there. So I think that was the hardest one on this assignment today. So we've got the hard part out of the way. Okay, number 3 wants us to see which chart. So the chart shows the average daily temperatures for a week in a town. So 86, 84, 88, 92, 88, 86, and 86. Well, while I'm making this video, it is currently April and snowing outside. So these 80-degree temperatures sound very nice. We all need to go on a vacation there. So which dot plot best represents the information? So we've got to look and see which one has an 86. Oh, I see 3, right? 1, 2, 3 86s. So we need to make sure we have one that has 3 86s. 1 84. I see 2 88s and 1 92. So it's a lot easier when they're already done for us. And that's a lot easier to visualize than trying to be like, wait, how many do we have? So see which one matches that information. Number 4, the dot plot shows the concentration of salt in samples of seawater from around the world. So this is how many grams per liter of salt there are in different places. So how many samples were taken? Another question is how many observations were there? So we're just counting how many samples they took. So each dot represents one sample. And then what fraction of the samples have a salt content greater than 38? So not 38 or greater, just greater than 38. So we're going to split it right here. So these ones, 1, 2, 3, 4, 5 of them have greater than 38, and our denominator is going to be out of the total. So we're going to take this answer here and put it as our denominator. 5 out of how many have salt greater than 38? So one thing, we do need to pay attention, right? Is it greater than 38, so bigger, or is it 38 and more? So pay attention to those words that we practice with those inequalities there. Number 5, a rectangular prism has a volume of 990 cubic inches. So volume, I know, is length times width times height. It has a height of 11, so I'm going to fill out what I know, and a width of 10. So width of 10. And what is the length? And we know the total is 990. So we can start by timesing 10 times 11. So 10 times 11 is 110. And we have L times 110 equals 990. So we want to bring everything down. So we did this part, bring it down. Now we need to get L by itself. So the opposite of timesing by 110 is to divide by 110 on both sides. So this cancels out. 110 divided by 110 is just 1. So we're left with 1L. So 990 divided by 110 will tell us the length of this rectangular prism. So remember, do what you can and then work backwards on both sides. So opposite on both sides. So it's important we show our work that we're keeping that equation balanced. Number 6 says write an equation for the statement. A kilogram is equal to approximately 2.2 pounds. A cinder block weighs X pounds. A brick has a mass of 0.6 kilograms. What is the total mass in kilograms Y of the cinder block and the brick? Okay, so that's a lot of information to dig through. So let's start with what we are looking for, an equation. So we know, right, 1 kilogram. So let's just write out what we know. 1 kilogram is 2.2 pounds. Or we could write it as a proportion and compare kilograms and pounds. 1 kilogram is 2.2 pounds. A cinder block is X pounds. So that is in pounds. So a cinder block is in pounds. And a brick has a mass of this many kilograms. And we're looking for our answer in kilograms. So the brick is done for us. It's already turned into kilograms. So that's nice. That one's done. So it looks like we would need to turn this cinder block into kilograms. So we don't know how many it is. So we want to get it in kilograms, and we know we have X. So right? We would do the opposite of both sides. So times by X times by X. So 1 times X is just X. And then we're going to divide by 2.2 will tell us the kilograms of the cinder block. So since we don't know what X is, we just leave it as X. So, and now it wants the total mass of the cinder block and the brick. So here's the cinder block, right? Cinder block. And I need to put the brick together. So we're going to add on the kilogram or the brick was 0.6. And it says that's going to equal the total of Y. So once we know X, how many pounds the cinder block is, we could divide that by 2.2 because that's what our proportion told us to do. Add on the brick, and that would tell us the total. So here is one way to write that equation. So remember, we could put 0.6 first. We could have Y on the other side. There's a lot of ways we can do this same problem. Okay, number 7, we're going to evaluate. So I'm going to simplify as much as you can when X equals 4. So let's substitute that in. So we have 3 times 4 squared plus 4 times 4 cubed. So remember, we've got to use our order of operations, our gems. So first we look for groups. Do we have any groups? No. Now we look for exponents. Write them out. What does this mean? 4 to the second power means we have 4 2 times. So 4 times 4 is 16. And we're going to multiply that by 3. And then we're adding on 4 times. Here's our other one is 4 times 4 times 4. 4 cubed is 4 times 4 times 4. Write them out. It's not 4 times 3. So 4 times 4 is 16. So now we need to do 16 times 4. So I'll let you do that. So put that here. Now, after we know that, we're going to, so we don't have any more exponents. So we'll multiply and we'll multiply. And then we're looking for adding and subtracting, and we'll add these two answers together. Okay, that is everything on your homework today. So if you have any other questions, be sure to let me know and we can set up a time to meet together.